Dang.
Let it rip.
Okay, we got I think we're still missing a couple people,
We're
but
gonna have a couple trickle in, I think. Yeah, 2 more, but I think we can get rolling because I want you to have enough time to do it justice.
okay. And I had to send Jeff the link. So apparently the two that I
Yep, yeah, Daniel's in here too. Yep.
Daniel's in there. Okay, all right. Just want to make sure. Okay, so I'm going to go ahead, and if I get to talking too fast, folks, just we're a small group. Please speak up. Please say, "Wait a minute. Please explain this," or "I have a question." And that's one of the beauties of having a small group. We can do that, and we can go from there. So please interrupt me. And I can't monitor the chat at the same time I'm talking very well. To the point I can't chew gum and walk at the same time. So anyway, these are the 2 forms that I have made up. And these are great for you to use for your classroom or for school competition, and maybe even going to a county competition. But these are made to be completed when you review that research plan, not at the end of when they're going somewhere else. So I'm going to click on this link, and I've got to stop sharing and then go to sharing what that looks like so you can see what it looks like. Okay, so this is the parent teacher one. Let me get rid of some of my things up at the top here so you can see more of the form. So this is the one that the parent and the student would complete, and you would make it for your school and send the link so it can be done at home. And you need to also send probably a link for the rules and that need to be read about the project that the student's doing. So it's basically what the name is, if there are any team members. If there are team members, every team member needs to complete their own, because we would have to have a separate signed parental form, or Form 1B, for every team member. So every team member has to do their own. Project working title, what the grade is, the name of the sponsoring teacher, the email of the sponsoring teacher. This is where it asks about things that need special permissions. Animals, yes or no. Humans, yes or no. Microorganisms, yes or no. Remember, elementary can't grow anything, microorganisms. Has potentially hazardous biological agents, yes or no. Was this a project from last year? Remember, that's a continuation form. Then where was the research done? And the reason I ask that is if it's done anywhere besides home or school, you have to have completed Form 1C, which is a form that talks about, has to be filled out by wherever you do the work. And it clarifies, and it has to be posted at the student project. So it clarifies, why was the student doing the project there? Were they there only to use the equipment? Were they part of an ongoing research project? How independent did the student work? Was it their own idea, or was it an idea that was given to them? These are really valid questions that help judges understand whether or not, how much of this was the student's project versus how much was handed to them. And then the name and the address of all non-school or non-work, non-home projects. A description of the project. This is not the full research plan, but it's just an idea of what it's all about. But the research plan has to be done by this point in time, because that's the next question. Research plan has been written and submitted for review to the sponsoring teacher. Then the parents, they have to say yes or no if they've read the rules. And then here's the ethics statement that is in Form 1B that has to be checked, and then the date that this was completed. So, and this needs to be completed by the parents with the students there, and then that date can be transferred over to Form 1B saying it was reviewed ahead of time. So that's why we have that. And now I'm going to open up the second one, if I can get there from here. All right, this is the one that I created for supervising teachers. or whoever is the sponsor, and a little information up at the top. The student names again, who's in here, whether it's 1, 2, or 3, that working title, who is the person that's filling this out, who's responsible, the email, and I need to put phone number in there, I missed that. Then you have to state the things that it asks you on that Form 1. You've read the rules and regulations, including the ethics statement. I reviewed the research plan, and this is where it's asking about those potentially things that you need to have special permissions for them. And I've put for you, yes, no, it contains humans, but we haven't done the form yet. Okay, that means you're going to have to get that form done. I've done it, vertebrate animals, yes, no, I haven't done it yet. Potentially, yes, no, I haven't done it yet. Hazardous chemicals, yes, no, haven't done it yet. Then all those haven't done it yet means that these are things that have to be completed and before the student starts their project. And then it gives the date of the approval for that, and that's time and date stamped as well. On all of these, you can look at the responses. I haven't answered any, so I don't have any responses. It can go as to a spreadsheet. And if you're supervising students, what you can then do when you're looking at that spreadsheet, look and see if you have any yeses under this animals, humans, microorganisms, potentially hazardous biological things. If you have any yeses from the students in there, then you as a sponsoring teacher know that you have to go to that student and you have to get those forms that it asks you about in your questionnaire. And you would fill out a questionnaire for every project and say, oh, that's going to take time. It's a lot less time than running off paper forms and trying to get paper forms completed and filled out for 300 students in your school. So this can help you out, but all of this should be done before they actually begin the experimentation. All right, so let me stop sharing here. Go back, oh, rats. Gotta go back. Just as I think I'm getting better at this sharing stuff, I skip a step. All right, so that's there to help you. And you can go back, you're gonna get a copy of this so you can work from there. I'm not gonna talk a lot about this because I already talked some about this risk assessment form 3. If in doubt as to whether it's needed, it never hurts to complete it, okay? Form 4, that first part of the top part of Form 4 is what the student and teacher supervisor fill out. The middle part is what the IRB or Institutional Review Board completes. And the bottom part is where you get the 3 signatures of your Institutional Review Board. I have gotten forms in where I have the 3 signatures on the bottom, but they didn't bother to check anything in the middle. So I've had to send it back saying, this isn't valid unless you've answered the questions in the middle. That's why you looked at it, is to answer the questions in the middle. The people that you need to have on this IRB committee can also serve on your scientific review committee, but you need to have an IRB for every school is the best way of doing it. If you don't, then maybe at least for your area. IRB is a science educator, cannot be the teacher who is supervising the student because that's a conflict of interest. A school administrator, so get your principals and assistant principals to aware of they need to look at projects that involve humans. They know whether or not this is something that they would let students do or they think parents would approve of. And then you have a qualified health or medical profession, and it lists a bunch of people as who are those considered. And at the bottom of this slide, it says that's examples of those are psychologist, medical doctor, licensed social worker, licensed clinical professional counselor, physician's assistant, nurse practitioner would be included as well, doctor of pharmacy or registered nurse. So your school nurse would work on this if you have one. or hopefully they come around every once in a while. And hopefully we'll be having more school nurses in the schools right now coming up and when we get to be live. But again, you can't have any conflict of interest, like a parent can't sign this. And I don't know if I told this group or the other group about the human subject form that was turned into me, and the only signature on it was the parent, and the parent was a beekeeper, and the student's project was on the effect of bee stings on humans. And the only test subject was her father, who also signed this form. And she was stinging her father on various parts of his body and measuring the reaction to the bee sting. Now, anybody else who had read that would have gone, no, you can't do this. And I have a good friend who is a research scientist and is also a beekeeper, and she went ballistic saying, does this man not know that you can develop allergies to bees at any time? And he could have gone into anaphylactic shock, as his child was.
Judy, if that teacher had allowed the parent to not only be the parent signature, but the expert signature, that would have been a problem.
I know. If the dad went in anaphylactic shock and, nobody else had reviewed it, you could come back and said, but you said you were the expert, but it's just not a good idea. Okay. All right. Microorganisms. In capital letters, no microorganisms for elementary students anywhere. Capital letters, no home culturing of microorganisms for anyone. So doing microorganisms with virtual classes and trying to develop science fair projects, do not do microorganisms unless they can go and work at a facility like a business or a hospital or something like that they handle microorganisms, or to a college or a university. They cannot grow them at home. This is not my rule, although I would have the rule. It is the rule by the International Science and Engineering Fair. If they do it at home, they are going to be disqualified. So please don't do that. If they work with microorganisms, now there are some things they can work with, like if they're doing composting, they can do that. If they look at yeast, they can do that. But one of the most dangerous things that students can do, and one of the things they really love to do, is swab everything in sight everywhere and then grow everything out, which means they have absolutely no idea what they're dealing with or what safety precautions need to be taken with what they have that they've cultured. So the ISEF rules say you can do these at school. Know that there are very few middle schools that really are equipped to handle this, but hopefully if a teacher approves it, they have some training in working with microorganisms. If you don't, then you may need to get someone. You would first of all have to have forms filled out that you have someone supervising it who knows something about it for safety issues. That requires special permission and has to be reviewed before they begin experimentation. So that gets us back to who reviews it besides you. When it's working with these potentially hazardous things, we have committees called scientific review committees, or SRC. So the link at the bottom of the page is the link to a checklist for the SRC review that ISEF has. But we have also given you, in all the documents you were able to download today, the link to those. There are a whole lot of documents and cheat sheets for being able to review projects, different types of projects, the process of doing it, and I gotta see what's the next slide is. No, okay. So the process of reviewing them, and there's actually one that looks like it's a PowerPoint, but if you click on the PowerPoint, it is a long video on training people to review projects, to be on a scientific review committee. That was developed again by Rachel Graham. And so that you have in your resources that you can pull down. I'm trying to talk quickly. I'm looking at my time. Conducting the research, writing the results, and presenting. We've talked about this a little bit. From the very beginning, have your students doing journaling. That is so important that journals be done from the very beginning, and everything is in there. Now, when you turn in the research plan for competitions, they'll need to make a copy of that research plan that we can see, but it will still be written in the future tense as if they were writing it in their journal. They can post, take pictures in there, they are photographs. As you can see this in this image of the journal, there are graphs that have been written in there, and it is also signed and dated. So your journal should be dated for every day that a student works on it. And that's great for you. I would recommend that you look at that journal every once in a while to see what the students are actually doing. This goes back to having a separate grade for each of these different components that we've talked about, so that students realize that each of these is important in learning that research or engineering process. Once they have collected their data, they've started their research, they need to figure out how they analyze it. And this is when you bring in your math people. The math usually in elementary projects is not as sophisticated, but when you get into middle school and high school projects, it becomes more sophisticated. And you want it to do that. That's part of what you're helping your students learn. So if you can have someone that can talk about statistics and why statistics are important and which ones make a difference as to whether or not they've collected enough data, what their graphs are showing, what their table is showing, how to identify the patterns, so they can learn what my data actually means. And this is a great collaboration between people if you're working with teams in your schools to be able to pull them in, or even, you know, ask if you have a friendly math teacher that would be willing to talk to your classes or give some examples. Ways of presenting your data, the flowcharts, schematics, tables, graphs. Photographs are underutilized and extremely important. If you go to a scientific meeting, they don't have a table full of things there, but they have the photographs that are needed to explain what they did in their backboard or their poster that they have brought with them. So encourage students to take photographs all the way through the process, and then they will have the ones that they need when they're pulling it all together, and don't have to try to recreate them. Drawing the conclusions of what they did, looking at the variables, seeing what actually caused change and how much change occurred, those relationships. Did it support your hypothesis? And this is one of the things that occasionally I'll have a student says, well, my project didn't work, my hypothesis was wrong, so I failed. Well, Manley, I'm going to let you tell your story because I love it.
I'll be fast. Thomas Edison inventing the light bulb, tried like 3,000 combinations of filaments, gases, and glass, and all kinds of things. 3,000 combinations, and before he got the right one, and a reporter said, well, Mr. Edison, how do you feel about 2,999 failures? And he looked at him puzzled. He said, we didn't have any failures. He said, what are you talking about? He said, I can tell you 2,999 ways that you should not make a light bulb. So he saw all of those as successes. He learned from every one of them.
So, and that's what you would need to stress with your students, that every time that they find out their hypothesis is wrong, that's another piece of information that we have added, that we now know, you know, that this is not the best way of doing it, so that we're not going to do that one again. But that opens up a new question of what can I do differently to get, you know, what can be my new way, my new method, my new hypothesis along the way. And looking at practical applications, something that is important for students to think about is how would you also change the experiment in the future if you were to continue working on it. So that is the end of what I was supposed to have covered in the first one. And so I'm going to blank that out, and I'm going to open up the next one, if I can find it. And part of the reason that we've got so much in these slides is because we want you to be able to have the information for you to take back with you. So now we're getting the point. They've got it all analyzed. They've come up with conclusions. Why do they need to present it? And that question comes up frequently. It's the more students practice presenting orally or even pulling it together as a research paper, the better they get. And it makes them actually think about that entire process that they've gone through and what they have learned along the way. It's great preparation, whatever they're going to do later. They have gotten time management skills if you have made them do it stepwise throughout the semester. It builds confidence because they have become an expert in a particular area or very small field. Those communication skills have been really increased. And it really gives students an idea as to what scientists and engineers really do, as to whether or not that this is something I might want to do in the future. And if they don't go into it, they have still learned how to ask a question and seek out ways to find the answer. And that's what we
It's not true.
Go ahead.
Sorry, Judy. And it's not true just because somebody said it. It's true because it's been proven and you have evidence and you can defend your position. And so science is always questioned, and it has to be proven with evidence. So that's a good reason to present.
Yes, it is evidence-based, and that's something that we need to have our students understand. Science and engineering is evidence-based, not conjecture or opinion. Okay, abstract. I get some really weird abstracts. I get some that have 20 words on them. I have some that they tried to give me their entire research paper. I don't want the research paper. I really want more than 20 words. It has a maximum of 250. The North Carolina form is a PDF typable form. You can put your data into it on the computer and save it with your name and then print it out as a gorgeous PDF that I can read. Instead of getting you, and when you print them out and have students write into them, I can't read their handwriting sometimes. And it makes it very difficult to follow up with them. I have had people that have printed it out and written in the top part or typed in the top part and then printed out and cut out a piece of paper that came from a word processor that had the abstract and taped that into the center. I get all kinds of variations, and then I have photographs made of the PDFs that end up being about 2 inches or an inch big when you try to look at it, or they're completely out of focus. So if you would encourage everyone to use the abstract form and type into it and save it with the student's name, I would love you forever. All right, so an abstract has only a couple of sentences in it. A few sentences about the purpose, a few sentences about the procedure, a few sentences about your data, and a few sentences about your conclusion. That's it. No bibliography, no references, no logos, no acknowledgments, and that's all that is in it. So it's got to be more than 20 words to be able to tell me that, but I do not want a research paper, okay? If they do a written paper, it should have in it, again, and I encourage you to bring in your English people, as long as they understand that the tenses will change in a scientific paper, that it's not all written in the same tense, which my English teachers growing up drilled in my head. It's different in scientific paper. And oral presentations, there are competitions like for middle school and high school, the North Carolina Student Science Academy, I was blanking. The Student Science Academy is for middle school and high school students. You send in the paper and then they do an oral presentation. It should go logically about what they're doing along the way. And then and I've given you some references on those. The poster presentation should not have the abstract on the board, but the abstract is on the table instead. So if the abstract's on the board, we make them cover it up with a little piece of paper that says summary, because ISEF rules say the only abstract is the abstract that we approve, and that is on the board. I mean, that's laid on the table for them to be able to use. It does not have any acknowledgments, okay? Doesn't have to have a bibliography on there. It can, but that's extra space that you can't get everything on there. It should have information about the project itself along the way. And one of the things that was discussed with me by Lisa Wycliffe, who actually conducted the National Junior Science and Humanities competition this summer, and they submitted PDF files of their backboards and did phone interviews. They learned that the students did the best when that introduction or purpose or the background, they included a couple sentences about why they chose that project. If there is a personal reason, a relationship of solving that problem for someone, or in science they were interested in this in particular and how it related to their interest, that it captured the judge's attention and the judges liked it. I will state photographs instead of stuff. Please think about photographs along the way. And let me move forward. And before we do the display, which Manley's going to talk about, I am going to see if I can hold up a book. This is a book that we used to give out to our one-day workshops and for doing the same thing that you are getting. And it is put out by NSTA, and it is entitled STEM Student Research Handbook. It was written for the high school level. It is excellent. It goes into all these things that we have talked about. It goes into not only the process that we've discussed, but also how to write a research paper, how to do an oral presentation, bibliography, and everything else. And if you're a member of NSTA, you can order it from them and you get a discount from the NSTA if you order it directly from them. So I would encourage you to look at that. It is easy to take the material in that and make it applicable for middle school students and even to elementary school students. I haven't found a good book for elementary school students in doing research, but this one has everything you would ever need to give you the background information that you can then transfer over to your students. So I'm going to go back to sharing screen, and we're going to talk about the display, and I'm going to let Manley talk.
Okay. The display is extremely important because that's what the student's going to use as a prop to help them defend their project, their research, and it's a way to quickly let the judges know what's going on. And they got to follow certain rules for their display. And one thing you'll see there is about the photo credits. One thing, if the student has people in the pictures, they're going to have permission for each person in the picture. So I would advise you right now to do your best not to have pictures of people in the photographs that are at the display. Now, having a hand in there holding something is different than being able to see the whole person in the face. So there might be a hand or something in there, but not a whole person, especially another student. Now, if there's a picture of the student who's doing the projects in there, they can say this, the parent's going to give them permission for sure to do that. And a lot of times the parents took the photo, but they're going to have to give credit to whoever took any photos they put on their display, whether it's a photograph they actually took or one they lifted from somewhere. They're going to have to give photo credit for that. However, that doesn't mean that's an acknowledgement. An acknowledgement is somebody that's helped them. I'm thanking somebody for helping me with this project, and that's not allowed. It says on the bottom here, no acknowledgements. I have seen judges when there's an acknowledgement there and they say, oh yeah, I recognize the professor that worked with the student there, and he really does some great work. And they already have an affinity to that professor. And whether that clouds their judgment or not, other people, if somebody heard that, they would think it would, and maybe other judges would think it would. So just to protect everybody, it's best not to have acknowledgements on there. Okay, now these are things, I'm not going to go through these, but these are not allowed at the booth. Make sure you look at this carefully. Had one a couple years ago that came to the state, and the student thought it would look nice. It was like an underground, the display had like a drawing of underground, and so she thought it'd be nice to put glue on there and sprinkle sand all over the project and whatever. And it says they can't have sand there. They can't have food. And I've heard parents will step up and say, oh, they didn't mean for that to be food, so it's not food. Well, if it's something that would be food, can't count. Or if it could be food, can't count. Anything living. So anyway, read this very carefully and make sure that you don't violate any of these things at the booth or on the board, even at the project. None of these things are allowed to be there, okay? And here's a project that from the ISF, the International, a couple years back, a student from Fayetteville, and she won an award here. You can see she's got a lot there, but she's got photographs on there. There's nothing really on the table. She didn't have to bring those things. She has photographs of what she used. It explains everything very well. And, hopefully the judges, and I always tell the judges, we're not just going on how good they look. And this one does look good. At the International, most of them do. But it's not how good it looks, it's what it says, what's there, and the data and the research. And that's really what the judges are looking for. You can see on the right side of the photograph, all those things listed are on the display. And it needs to be neat and clear. And she found a way, this student did, of getting a lot of information up there, but still having it neat and not overwhelming. And the judges could look at it for a few minutes and really figure out what she did. And if you have a journal, she has, it looks like there's around the corner, there's a journal. It's good to have the journal or logbook there. They may ask you about your data and you can consult your data or whatever. That's allowed, and we encourage that to be there. Another one, Judy, do you have something? This is not one of ours, I don't think.
Yeah,
There's
these are
another
some
from
these are some that I pulled from the internet.
journals. Yeah. Now this one has abstract. One thing they're picky, ISF is picky about one thing. We have on the table in front there, we have something, we have the abstract and some documents like that, and the safety display information or the SRC information showing that it's qualified and all that. But they aren't allowed to use the word abstract up on the top left on the board. They could have put the word summary. It could be a summary of what they did, and that would be fine. But the abstract is, the official abstracts there got a seal on it, it's on the table. So they're not to put abstract on the board. That's a little picky, but anyway. Now this one has major violations. This is what you do not do. If you had just a display with the photos and all, that's great. But once you start putting things out there, like all these acids and harmful substances that are supposed to corrode metal, students walking by could pick them up. Younger brothers and sisters could sniff them or maybe even drink them or pick them up and pour them on somebody accidentally. None of that stuff should be there. And on top of that, they brought some examples of rusty, corroded materials like a rusty saw and a hoe. I guess there's a vise there as well. None of the stuff you see on the table would be allowed. It would have to be removed. And we hate to remove something at the fair, but we have to do it. And the students feel like they're now at a disadvantage because it was removed. But this student does have pictures of everything, so there's no need to have it. Okay. And this one came from another place. The students' names are on there. We wouldn't use it if they were North Carolina students. But anyway, this was just too busy. They got too much up there. I'm guessing they probably don't even have, it's got literature cited. And so that may be for their literature, but the photos were taken from somewhere. They're probably not cited on there. All those different images and whatever aren't cited. And she might have acknowledgments in the lower corner. I don't know.
Yes, she does.
Those are not allowed. A lot of problems with this one. This one's pretty busy, and she really didn't need everything there. A lot of things in the middle on the right side are there just to dress it up.
One of the questions that I get frequently is, can they have their name and school in the front? Well, ISF states that you can legally have on the front of your board anything that is written on the top of the abstract, which is the student name, the school, and the city that the school is in. However, I have a lot of fairs that require the student to have their name on the back, so it cannot be seen during judging. And the reason being, if you're from a really small town, a lot of people know everybody, and they may be neighbors or go to church with a student. and kind of go, well, I know that student really works hard and they do a great job and they're really smart. So it can actually affect sometimes the judging. So a lot of places will make sure that only the title is on the front and the name is on the back so the student can find it, but it's not obvious for judges.
It's better not to have it on there, have it on the back. Exactly right. Okay, now this one, on an engineering project, they can usually have a model as long as they haven't violated any other rules about things you can't have food and things there, and they can have wood that's been processed, that's been purchased as wood, so that truss that's there is allowed. However, I do question, that's just a standard truss and it's not really showing anything, and it actually shows the weakness of this project because the student just tested something that already exists out there. It's not anything new, but it is allowed.
And they also stuck a yellow card up there of acknowledgements. So
is that acknowledgements? Okay, so they can't have that either. But they do have to tell where the photos were taken, and hopefully this student is the student who did it that's in the photos. If not, they'd have to have permission from the parents of every student that's in the photos. Okay, now if you're going to run a fair yourself, we'll be glad to help you this year. We'll make this offer now. You can call us up. We'll help you. We were talking to Sherry before we got started. And there's a lot to do. And if you're going to run a fair yourself, you're going to have to really look carefully at that timeline, knowing that most of the fairs, the state fairs, later in the year, but the regional fairs are in February. One for Region 7 is in January this year, and usually it's in December. But you're going to have to work backwards from there and have your fair in time prior to that to get into the regional fair. And don't do it alone. Have these committees set up. And you can have different people in charge. I'm not going to read all these to you, but you have all these different things that people could be doing to help you make the fair a success. And it might be you have the fair in the gym or somewhere where younger students can go through and your students could practice and have them tell what they've done, and they can ask them questions. And it's really good for the younger students to see that. And then they can have the actual fair, choose the winners, and you got to get them entered in the regional. I think it's a good idea to let the regional director know that you'll be sending a certain number of projects later so they can expect it. And then, okay, Judy, I think this is back to you?
Yeah, I'll go ahead and talk about that. In the handouts that we've given you, where there are some tools to assist you in running the fair. And Manley and I are happy to help you if you have issues and to help you along the way. And I can stay online till later because I think we're going to run out of time to be able to go over this. The tips and tasks, and that's what it's for local science fair directors, is written as a Word document, and it has a lot more than what you'll probably need for a school fair or even a county fair, and even for some of the regional fairs. But it's where we tried to think of everything possible that would need to be considered and when you would need to start thinking about it along the way. So you have that document. You also have an Excel spreadsheet that has the fair planning guideline. And I may see if I can get out of here. Hold on. I can't get out of, I'm gonna have to stop sharing. Okay, hold on. Share a different screen. Okay. All right, so this is the fair planning document. And I think I'm sharing that. So you type the date of your fair and it will backtrack how many days you now have to do it. So again, this was developed for the state fair. We have now modified it for us. And we redo this every single year. We take the one from last year and then we change the date on the front, and then we can see who did it last year, and we can go through at the beginning of the planning season and say who's going to be responsible for it this year. We have notes off to the side as to things we ran into and what the status of it is, but it really helps you think about everything. Again, you probably aren't going to need all of this, but it's there to help you in planning, and it's little things about arranging for tables, so you don't forget those along the way. This is the checklist that I told you about, and it's written, and you've got a copy of this, a digital copy. And then let me get out of this, stop sharing, and then get back to this one. Okay, so we also have given you in a folder a lot of scientific review cheat sheets, and I mentioned those earlier, but they're in that same folder. So this gets now into judging. And Manley, I'll let you talk about judging a little bit.
Let me unmute now. Now, on the judging, you can get your judges from lots of sources, and I think it's good to have an orientation. I don't know if we said this last night, but when you have the judges and they come to the fair, you probably need to have a little orientation with the judges to get on the same page. One thing I do not recommend is giving everybody a rating sheet and then having them come up with a score and then adding all the scores together or something like that so you've got the highest score. Typically at a school fair, when you do your school fair, you got your categories, you get the judges to know each other, they talk, and you want them to all see all the projects in that category. You want every student to be talked to by at least a couple judges, and not at the same time. It'd be nice that way they don't stand there for 2 hours just to say something one time. They can, the judges can be going back and forth through there and the students can be talking with them. And then ordinarily the judges need to confer, and maybe they might pick their top 10 projects and they might have to go back and look at them again, maybe even ask them more questions. But you want them to really confer, not just to judge. They can judge independently, but they need to put their heads together and whatever. And they want to make sure that the students did the project, and I won't go into stories, Judy, I know I got a story I usually tell here, but lots of times you can look at a project and it's very well done, and it's possible you look at it, it's very well done, and you think they didn't do it. But when you talk to the students and ask questions, you realize they did do it. And sometimes you get fooled the other way. It looks pretty good, and you get talking to them and realize they don't know a thing about it at all. And so it's important that the judges talk to the students and find out what they did and their method, and the students are just great. This is wonderful. They should be doing it. Anything you want to throw in, Judy, about that? Because I can read the rest of the slide.
I really encourage you to look at the judging criteria. You've got that handout. This link will take you to the ISEF website, and it talks about judging projects and talks about, just training judges and having conversations with judges before they start. I've given you that as I think it's as a Word document, maybe as a PDF, and it will have some background information, and it talks like originality is the originality of the topic or the question, not how creative they are, etc. But it gives you a different scoring rubric for scientific and a different scoring rubric for engineering type projects. And out of that, 35 points come from the actual presentation, where you get 10 points from the backboard and you get 25 points of that come from the interview with the student. And we really encourage students not to have a canned talk as much as being able to have an introduction and then be able to answer lots of questions. So,
and one thing that may not show up on the criteria or the sheet is, a lot of times the children are, especially if they're younger, or maybe are a little afraid of the judges. And so, you let judges know that the kids are maybe a little uptight about it. So they want to make sure when the judges come up, first thing they're going to do is, be very friendly with the children and not, and ask some questions they can't answer. They may want to do a little presentation, but the questions that they ask can get progressively more difficult, but not start out with the tough questions, and the kids feel like they're being drilled right to start with. But they do need to get some important information from the students. And I think with the judging, it's also helpful to walk through and look at the projects first, and look at the projects without anybody there before, and then have the students come in rather than having them stand there forever. But they can learn a lot and think of questions they want to ask by looking at them, and they don't feel comfortable doing that with a child standing there. So, you might want to at first have them walk through, see everything, then bring the children in and they can go down the line. Okay.
So this is our 5-minute warning. I just wanted.
All right, Judy, you having more on this one? Okay.
Okay, I'm going to talk real quickly. Communication. 2 years ago at the State Science and Engineering Fair, I had a family walk in carrying, with a little girl carrying her poster she was very proud of, and we knew absolutely nothing about them at the state level. The teacher had registered them from the school fair, had registered them at the regional fair, and they had been given all the information. The student family had been given all the information about registering for the state fair and where it was going to be and when, and they had been getting emails because they had moved forward in the system, but they had never bothered to register because they thought the teacher was registering them for them. So communication is really important, especially with students that are moving forward. That paperwork, if they're going to a regional fair or to a state fair, is important. At your local school and local fair, you can get away with using that Google form because you're collecting all of the data that is on the required forms, and it's asking you to make sure you do complete forms for those that are required to have special permissions. When the students come, may remember that they need to bring all of their journals, all of their lab books. When they send paperwork in, if they send it electronically, that's great. They need to also make sure they have a copy or the originals of the paperwork they can use, because sometimes something happens, and I would encourage them to bring them with it. Make sure they read those display and safety rules before they get there. So I did check the links, and they still work. There's some links that will give you some good information that you can go to along the way with qualifiers. And hold on, I clicked on one of them by accident. So I went out. Okay, let's get back here. So we're going to look at a couple of alumni videos, but before we do that, I want to say thank you to all of you who have been attending. And we will be having a lot, and I don't think I mentioned this before, have been working, Teresa has put an awful lot of work into it, and our webmaster, of collecting videos or photographs of students with their projects from this past year, since we did not have a live face-to-face fair. This was completely optional. It was only, so the students that will be on the website are those that wanted to send in a presentation or a picture of them with their project board. So it was not required. And, so it was only the people who wanted to do it that sent it in. We didn't solicit anything by anyone other than asking them to get it. So the evaluation link will be sent to you before Teresa closes this out. And so we will need your evaluation, and I will be looking at the research plans and sending information to you. You have until 8 p.m. tonight to send it in. And if you have something urgent that comes up, email me and we'll see if we can't work it out if it needs additional time. And Teresa's also going to send the link later. So now to look at these, and I'm probably going to have to stop sharing and share this so that you can see it.
If you have to drop off, you have to drop off, okay?
All right, I will stay on for a while if you want to ask questions, because I know that there are a lot there. Okay, this is one young lady. And I'll make this big. Make sure my volume's up.
My name is Lauren Sanders, and I'm a 10th grader at Northwake College and Career Academy. I participate in the MSCN pre-college program, as well as being a Girl Scout and volunteering at Marbles Kids Museum. Something that I really love is science, and that love was instilled to me by my parents. So doing the fair and being in the science fair was kind of, there was no questions asked about it. I saw that we were having a science fair at my school, so I was just like, I probably should do that. So the first year that I did it on essential oils and the effect of essential oils on bacteria. I got 3rd place in my category for that in my school, but I didn't go to regionals that year. Then the next year, I did my science fair project on ancient wheat versus modern wheat, and I won first place in my category. So I progressed on to regionals, where I won third place in my category. So that was a lot of fun. And being at regionals was one of the best experiences because I was able to not only see other people's research, but I was presenting my research, seeing other people's research, and getting judged on my research. So it was kind of nerve-wracking, but it was a lot of fun. And being alone and not having a team, that was a different experience for me. But I learned a lot more confidence. And as the day progressed, I was able to change my aspect, change my way of presenting, because it was a lot easier to do it a different way rather than the way that I had originally planned. And seeing the reaction of the judges when they saw my research, and a lot of them hadn't heard of some of the types of wheat that I was talking about, but it gave them a chance to open their minds, as well as seeing my own mind open while I saw other people's projects and all the cool ideas that they had as well.
Okay, so for some reason this repeats itself. So now I'm going to take you to the second project. Now, Daniel Holler is at NC State University now and has won, through the research that he's doing at the university as an undergraduate, the Goldwater Fellowship, which is $7,500 each year for him to use, depending upon when he got it, his junior and senior year, or just his senior year, depending. But it also is extremely prestigious, which will set him up for graduates to get accepted in graduate school and get all kinds of other funding. But I took him 2 different years to the International Science and Engineering Fair. So here is his story.
Hi, my name is Daniel Haller, and I am an undergraduate student at NC State studying chemical and biomolecular engineering, and I am an NC Science and Engineering Fair alum. I grew up south of Charlotte in Union County. I went to Marvin Ridge High School, and I want to tell you a little bit about the experiences that led me to get interested in science, led me to participate in NC Science and Engineering Fairs, and led me to where I am today, which is working in research. I've always been really interested in science. I'm sure like many people watching, I grew up, both of my parents are engineers, so science has always been a part of my life. What got me into the research world was a really exceptional teacher who not only sparked my interest in biology, but also helped me realize that I really wanted to try this research thing. So I began to participate in science and engineering fairs, and it was a really great decision. I think the biggest impact that doing these research projects has had on my learning and my career path is it gave me the problem solving skills that are really, really useful in real research. When you're doing a classroom assignment, everything is laid out for you so that you know how to solve each step as you go along. But in the real world, you're coming up with solutions to problems that haven't been answered yet. And you're asking questions that no one has asked before. So I think participating in science fairs where you're coming up with your own questions and working through the problems all by yourself is a really, really great experience for anyone who's interested in science and anyone who might think that research is possibly a career for them. One of my favorite experiences with science fair was going to the International Science and Engineering Fair, or ISEF. I got to attend a couple times. And that was a really cool experience because I got to meet people from all over the world who had similar interests to me and were also interested in cool aspects of science and trying to create things that would help people. And I formed relationships with people from around the world that I keep in contact with a lot of them today. If I had one piece of advice for people who are interested in science, possibly as a career or just for some fun, explore all of your interests, not just those you think you might major in college or pursue a career in. An interdisciplinary framework is becoming so important, not only in research, but in industry and all over the place. So pursue not only your interest in science, but also your curiosity in other areas as well. And all of those things will support each other as you move forward.
Okay, so that brings us to the end of the session. And I can hang out for a while to be able to answer any questions that you have. But I do want to say thank you again, and I hope we didn't rush through things too quickly today or in previous sessions. It tends to mushroom on us as we start talking and we get carried away, and then we realize, oh, we need to tell you this. So, and I also apologize for, this is not as great as if we were face-to-face, where we were able to have you do things with us and we could be able to mentor you like in the projects at live as you were working on it, and you could work better in teams. So we are available. I think Manley and I are both be happy to answer any questions that you have, not only today, but also in the future, if we can.
Good luck and stay safe. We're going to stay here. If you have to drop off, that's okay, but we'll stay if you got questions. And you can just unmute to ask the questions.